Hello everyone, hope you are doing good. Myself Dr. V. Gopalakrishnan, belongs to Physics Department, Dr. N.G.P. Arts and Science College. Here I am talking about the course name of Thermodynamics and Statistical Mechanics. In the topic of Thermodynamics, Microstate and Macrostate. In this video, we are going to see about the basic postulates of thermodynamics and the basic definition of phase and ensembles. Followed by that ensemble, we're going to see about the classification such as microcanonical ensemble, canonical ensemble, grand canonical ensembles. And finally, we're going to see about the microstate and macrostate. Let me see one by one. Here, the basic postulates of the thermodynamics. In general, the properties of individual particles are of no interest in thermodynamics. Actually, thermodynamic discussion concerns the macroscopic state of a system, which contains information only about quantities that are defined macroscopically. So that the basic postulates of the thermodynamics are the statement about the macroscopic state of the system. There exists a particular state of any system which can be completely characterized by a set of extensive parameters, including its internal energy, pressure, kinetic energy, such as. These states are called as an equilibrium. Here, I want to tell the actual meaning of extensive parameter. That is, if we have two exact copy of same subsystem and consider the whole thing as our in system, the internal energy of the total system is twice the value of the same quantity of each subsystem. The same can be said about the volume of the system. If subsystem has volume V, the two copy of a subsystem will have a total volume 2V. So those who have such like parameter, which is known as extensive parameter, that exists a function of extensive parameter called the entropy and denoted by S, which have defined by all the equilibrium state. It has the following unique property. The entropy is an continuous and differentiable, and it is a monotonically increasing a function of internal energy. When all other extensive parameter, it is a constant. The entropy of a composite system is an additive over the constituent subsystem. In other words, entropy is an extensive parameter itself. Finally, if a state of the system is not in equilibrium, it is entropy will be less than the entropy of the equilibrium state with the same value for all extensive variable. Left to itself at the fixed value of the extensive parameter, then non-equilibrium state will gain entropy and try to attain the equilibrium state. Here, I mentioned the phase space. In classical mechanics, the state of a system of particular particle at any given time is completely specified by the knowledge of position and momentum of each of its particle. The instantaneous position of the single particle is determined by the three independent coordinates of x, y, and z. Similarly, the instantaneous motion of the particle is described by velocity component such as vx, vy, or vz. Or more conveniently, it's going to specify by position coordinates such as px, py, and pz. Therefore, the state of a single particle is then completely specified by the position coordinate x, y, z and momentum coordinate px, py, pz. So simply, through a mathematical concept, we may imagine Six-dimensional space will be described by a set of six coordinates such as x, y, z, px, py, pz. This six-dimensional space of a single particle is termed as phase space and particularly mu space. And we can understand the actual meaning of the phase space by this diagram. Obviously, the dimension of the phase space depend upon the degree of freedom of the system. The instantaneous state of the particle in the phase space is represented by point known as phase point or representative point. The number of the phase point per unit value is called as phase density of the point. As element of the value in the phase space is termed as a cell. So here we discussed about the phase point, phase density, and phase cell. In this slide, we're going to see about the ensemble's definition and the classification. A system is defined as a collection of number of particles. An ensemble is defined as a collection of large number of microscopically identical but essential independent system. By the term macroscopically identical, we mean that each of the system constituting as ensemble satisfy the same macroscopic condition. Example, value, energy, pressure, total number of particles, and so on. By the term independent system, we mean that the systems constituting an ensembles are mutually non-interacting. In ensembles, the system plays the same role as the non-interacting molecules do in a gas. The macroscopically identity of a system constituting an ensembles may be achieved by choosing the same value of some set of macroscopic parameter which uniquely determined by the equilibrium state of the system. Accordingly, there may be the many types of ensembles. Out of them, the most widely represented the classification of microcanonical ensembles and canonical ensembles and grand canonical ensembles were represented here, and we can easily identify the actual meaning of these three classifications through by this diagram. In this slide, we're going to see about microcanonical ensemble. The collection of a large number of essentially independent systems having same energy, value, and number of particles. For simplicity, we assume that all the particles are identical. The individual system of a microcanonical ensembles are separated by rigid, impermeable, and well insulated walls, so that the value of EVN are not affected by other system. And the table here listed out and their basic parameters also identified here. Here we're going to see about canonical ensemble. As like in microcanonical ensembles, the canonical ensembles also have the independent, the collection of number of particles of essentially independent system having the same temperature, volume, and number of particles. The individual system of a canonical ensembles are separated by rigid, impermeable, but in conducting wall, so that the value of volume and number of the particles are not affected by other system except temperature, because the temperature is a common to all the system. And here the listed out the tables where represent the what are the basic parameters holds in canonical ensembles. Finally, we're going to see about the grand canonical ensembles. It is a collection of large number of essentially independent systems having the same temperature, value, and the new parameter compared to microcanonical and canonical. Here we have chemical potential. The individual system of a canonical ensembles also separated by rigid, impermeable, but in conducting wall. As like the grand canonical ensembles also have rigid, impermeable, and also a conducting wall. Since that the temperature and chemical potential is an common to all, and the value is an specified in the specific subsystem. It is not common to for all the system. And here the listed out the tables where represent what are the parameter holds in grand canonical ensembles. In this slide, we are going to see about the microstate and macrostate. Here we should understand and we should recall what are the definition we discussed in the early slide about the phase phase, phase point, and ensembles. Based on that only, we are going to define the microstate and macrostate. For microstate, the ensemble must be specified the individual position of phase point for each system or molecule. For example, the density of the same if the number of molecule in each volume element of ordinary space is the same regardless of which particular molecules in the any volume element. Similarly, for macrostate, the ensemble may be defined by the specification of number of phase point in each cell of the phase space, such as N1 phase point in N1 cell, N2 phase point in N2 cell, similarly N3 phase point in N3 cell. So here every particles were identical and which is specified in microstate and macrostates. Summary of this video. Here we have seen the basic postulates of the thermodynamics and what are the important parameter if it is in equilibrium state or not in equilibrium state. Followed by that one, we discussed the definition of the phase space and ensembles, and also we discussed the classification such as microcanonical, grand canonical, and canonical ensembles. Finally, we saw the microstate and macrostate importance. Hope you may enjoy this video. Thanks for watching this video. Thank you.